Picture this. You are standing in a field on a clear night, not in a city, not near any light pollution, somewhere far enough out that the sky above you goes from horizon to horizon without interruption. The stars are out in numbers that most people who have spent their lives in urban environments genuinely never see. The Milky Way is a smear of white crossing overhead, and it looks like a photograph, like something frozen in place, like a ceiling painted by someone with extraordinary patience and an unlimited supply of white flecks. It looks absolutely, completely still. That impression is wrong. Not slightly wrong, not wrong in a technical footnote kind of way. Wrong in a way that inverts the entire picture once you understand it. Your whole life, that picture has been reinforced. Museum exhibits and textbook diagrams show the universe as a collection of objects, static things at static positions, just very far away. Stars here, galaxies there, distances that make the word vast sound inadequate. But things, objects, stuff in space. The impression the whole apparatus of popular science communication delivers, without quite saying it directly, is that space is a place where things sit. The universe is not a place where things sit. It is a place where things move. Everything in it is moving. Every single thing. From the electrons in the atoms of the grass under your feet to the galaxy clusters on the other side of the observable universe. Nothing is at rest. Nothing has ever been at rest. And the motion does not just happen at the small scales, the subatomic, the molecular, where we might be comfortable accepting it as physics, rather than something we need to confront in our picture of the sky. It happens at every scale simultaneously. Organized, structured hierarchical motion, with each layer nested inside the next, each orbit carrying the thing it contains into the orbit above it, all the way up to structures so large that their motion requires millions of years for a single cycle to complete. That field you are standing in is not standing still. It is moving at a speed that would reduce it to debris in an instant if you could step outside it and let it pass. Get comfortable. Hit subscribe if you are new here, because by the end of this, stillness will never mean the same thing again. The motion beneath your feet that you cannot feel. You are rotating right now, not in the sense of spinning, not in the sense of feeling dizzy, but in the cold, objective sense of your position on the surface of a sphere that is turning on its axis at a speed that depends on your latitude. At the equator, the surface of the Earth moves at roughly 1,670 kilometers per hour. Let that number settle. Not the speed of a fast car, not the speed of a commercial aircraft. Faster than most military jets at top speed, faster than almost anything you have ever ridden in or on, and you feel nothing. No wind, no vibration, no sensation of motion whatsoever. The chair you are sitting in is moving at the same speed. The air around you is moving at the same speed. The building around you, the ground beneath you, the entire atmospheric envelope of the planet, all of it rotating together, a coherent system in which every component is swept along at the same rate. And so none of it registers as motion to any sensor in your body. You were built to detect relative motion, the movement of one thing with respect to another. When your entire reference frame is moving uniformly, the physics of your senses is identical to being at rest. You cannot tell the difference. Evolution never needed you to be able to, and that is the first layer, the rotation of the planet. Roughly 1,670 kilometers per hour at the equator, declining toward the poles, but nowhere zero, nowhere still. Earth orbits the sun. This is not just a fact you learned in school. This is a real physical motion happening right now at a speed that makes the rotation look modest. Earth travels around the sun at approximately 30 kilometers per second, not per hour, per second. 30 kilometers in the time it takes you to say the word second. In the 10 minutes it takes to read this first section, Earth will have moved roughly 18,000 kilometers along its orbital path. You feel none of it. The same logic applies. You are inside the moving system, the solar wind, the planets, the inner asteroid belt, all of it orbiting the same sun, all of it in the same rough frame, all of it moving together, so that the relative motion is negligible at the scales your body can sense. But here is where it starts to become genuinely strange, because these two layers are just the beginning. The sun is not sitting still. This seems obvious when you say it, but the full implications take time to absorb. The sun, the star we orbit, the object at the effective center of our local system, is itself in motion, not drifting aimlessly, but in a structured orbit around the center of the Milky Way galaxy, sweeping through the galaxy at approximately 230 kilometers per second. 230, 7 times faster than Earth's orbital speed around the sun. The sun has been doing this for the entire 4.6 billion year history of the solar system, completing roughly 20 full orbits of the galaxy in that time. We are not parked in one spot in the Milky Way. We are traveling through it, and the orbit takes a long time. One complete circuit around the galactic center takes approximately 225 to 250 million years. This unit, 1 galactic year, is so large that in the time since the solar system formed, life has gone from single-celled organisms to everything alive today in the time it takes us to make about 20 laps. The last time the sun was in its current position relative to the galactic center, the Triassic period had just ended on Earth. Dinosaurs were just appearing. That was 1 galactic year ago. 1 lap. The Milky Way is moving. The galaxy itself, the entire structure of 200 to 400 billion stars, its spiral arms, its central bulge, its enormous dark matter halo extending far beyond the visible disk, all of it is moving. Moving with respect to what? Moving with respect to the local group of galaxies, the gravitationally bound collection of roughly 50 galaxies, of which the Milky Way and Andromeda are the 2 largest members, and moving with respect to a fixed background that is more fundamental than any local reference, a background that represents the deepest possible definition of what at rest actually means in a universe that is expanding in every direction. That background is the cosmic microwave background radiation, the faint thermal glow left over from the early universe, the fossil light of the Big Bang stretched by 13.8 billion years of cosmic expansion until it sits at microwave frequencies, filling the sky in every direction with a near-perfect uniformity at 2.725 Kelvin. This radiation fills all of space. It comes from every direction with equal intensity. And if you are moving through it, if you are not at rest with respect to the average distribution of matter in the universe, you will see that background radiation very slightly blue-shifted in the direction you are moving toward, and very slightly red-shifted in the direction you are moving away from. A tiny but measurable asymmetry that reveals your velocity with respect to the cosmic rest frame. Measured against the cosmic microwave background, The solar system is moving at approximately 370 kilometers per second in the direction of the constellation Leo. 370 kilometers per second. If you combined that speed with Earth's orbital velocity around the Sun, the two motions happen to be roughly aligned in certain directions and opposed in others, so the total velocity of any given point on Earth relative to the cosmic background oscillates between roughly 340 and 400 kilometers per second, depending on the time of year and the time of day. You are, at this moment, somewhere in that range, moving at some fraction of a percent of the speed of light, relative to the deepest available reference frame the universe provides. And none of this accounts for the fact that the local group of galaxies, the whole collection including the Milky Way, is itself being pulled toward a large mass concentration in the direction of the constellation Centaurus called the Great Attractor, and beyond that toward an even larger concentration called the Shapley Supercluster, at roughly 600 kilometers per second relative to the cosmic background. The motions layer on top of each other, all simultaneously real, all simultaneously happening, all simultaneously unfelt. When you are standing in that field looking up at the stars, you are doing so from the surface of a planet, rotating at up to 1,670 kilometers per hour, orbiting a star at 30 kilometers per second, which is orbiting the galactic center at 230 kilometers per second, which is part of a local group moving at roughly 600 kilometers per second toward a mass concentration that is itself part of a larger structure in an expanding universe. Every star in your field of view is doing the same thing, each one in its own orbit at its own speed, sweeping through its own layer of the hierarchy. The sky is not a ceiling of still points. It is a snapshot of an enormous moving machine, taken with an exposure so short that nothing appears to blur. The stillness is a trick of scale and time. It is not the truth, what motion actually means at cosmic scales. We have established that everything is moving, but to go further into what this means, to understand why it matters and where it leads, we need to think more carefully about what motion is in the context of the universe, and why the universe has organized its motion into the structures it has. The first thing to understand is that random motion and organized motion are different. In a cold cloud of gas sitting in interstellar space, all the particles are moving. Gas particles at any temperature above absolute zero have kinetic energy and therefore velocity, but that motion is random. The particles move in all directions with a distribution of speeds, bumping into each other, exchanging energy, collectively going nowhere in particular. If you average over enough particles, the net motion of the cloud as a whole might be quite small, even though every individual particle is moving fast. Orbital motion is different. It is structured. It has a direction that is persistently the same, that carries the orbiting object in a consistent curve around a gravitational center, that preserves angular momentum over time. When a cloud of gas collapses under its own gravity to form a star or a solar system, the random component of the motion gets dissipated through collisions and radiation. The organized component, the net angular momentum of the original cloud, gets concentrated into the rotating disk and the spinning central object. Angular momentum cannot be destroyed. It can only be transferred. And so, the rotation of every star and every planet is a direct inheritance from the initial turbulent motion of the gas cloud that formed it. The sun is spinning because the cloud it formed from was spinning. Earth is orbiting because the disk it formed from was orbiting. The angular momentum has been there all along, just organized into its current form. This is the deep reason the solar system is flat. Not flat by coincidence, not flat because flatness is a natural shape for collections of objects, but flat because a rotating system that collapses under gravity naturally settles into a disk, with the angular momentum that was spread through the original cloud now concentrated into the orbital motion of the disk's contents. If you had a differently shaped initial cloud with different turbulent motions, the disk would be tilted differently. The shape of the solar system is a fossil record of the motions in the pre-solar gas cloud 4.6 billion years ago, and the same logic applies at every scale. Galaxies are disks, broadly speaking at least the spiral ones, because they formed from rotating gas clouds. Galaxy clusters are organized the way they are partly because of the motions of the structures that merged to form them. The cosmic web of filaments and voids that structures the universe at the largest scales is a direct consequence of the small-scale density variations and velocity fields that existed in the very early universe, which were themselves set by quantum fluctuations during inflation stretched to cosmic scales. The motions in the universe right now are the echoes of much older motions. Every orbit is a memory. Every rotation is an inheritance. The galaxy you can see in the sky tonight is spinning the way it is spinning because of the velocity field that existed in the gas that collapsed to form it billions of years ago. It has been carrying that angular momentum ever since, the speeds that nobody talks about. We covered the hierarchy in rough terms in Part 1, but the numbers deserve more attention because the human mind is good at accepting numbers as facts without letting them actually land. Let us let them land. Earth's orbital speed around the Sun is 30 kilometers per second. For comparison, the fastest crewed spacecraft in history was Apollo 10 on its return from the Moon, which reached about 11 kilometers per second relative to Earth. Earth in its orbit is nearly 3 times faster than the fastest humans have ever traveled, and Earth is in the slow lane. Mercury, the innermost planet, orbits at about 47 kilometers per second. The escape velocity from the solar system at Earth's distance, the minimum speed needed to leave the Sun's gravitational grip entirely, is about 42 kilometers per second. Earth is moving fast enough that it only stays in orbit rather than escaping because the orbit curves it back around. If you could somehow instantaneously redirect Earth's orbital velocity straight outward rather than perpendicular to the Sun, the solar system would not hold us. The Sun's orbital speed around the galactic center is 230 kilometers per second. Again, this is the actual speed of the physical motion of our star, our Sun, through the galaxy. The galaxy is not small. The Sun's orbit has a radius of approximately 26,000 light-years from the galactic center. The circumference of that orbit is roughly 165,000 light-years, which at the current orbital speed takes 225 million years to complete. So the Sun has been orbiting for 4.6 billion years, divided by 225 million years per orbit, which gives roughly 20 complete orbits since the solar system formed. 20 times around the center of the Milky Way, and each orbit is 165,000 light-years long. The total distance the Sun has traveled in its galactic orbit since forming is roughly 3.3 million light-years. The Sun has moved 3.3 million light-years through the galaxy since the Earth formed. In a galaxy roughly 100,000 light-years across. And now, the solar system's total velocity relative to the cosmic microwave background, somewhere around 370 to 400 kilometers per second, depending on which components you include and how they happen to be aligned. 400 kilometers per second. That is 0.13% of the speed of light. Still comfortably below relativistic territory, but a genuinely large fraction of a percent. If a spacecraft could travel at the speed of the solar system's motion through the background, it would cross the diameter of the observable universe in roughly 115 billion years, which is 8 times the current age of the universe. So not fast enough to cross the observable universe in any reasonable cosmological time, but fast enough that the numbers are no longer completely negligible. These speeds are real. They are happening right now. The total velocity of the ground under your feet at this moment, adding up all the layers, the rotation, the orbital motion, the galactic motion, the peculiar velocity of the local group, is somewhere around 400 to 500 kilometers per second relative to the cosmic rest frame. Depending on the time of day and time of year, the different components add together slightly differently, but you are always doing several hundred kilometers per second minimum relative to the deepest background the universe provides. And you feel nothing because you are inside it, the galaxy itself. What is actually happening up there? To appreciate what the Milky Way actually is as a physical structure in motion, you have to abandon the idea that it is an object, or at least you have to abandon the idea that it is an object in the way a rock or a planet is an object. A rock is made of atoms that are bonded to each other. When the rock moves, all the atoms move together because they are connected. The rock maintains its shape and structure because the chemical bonds are doing the work of keeping everything in relation to everything else. A galaxy is not like that. The stars in a galaxy are not bonded to each other. They do not touch each other. The distances between stars in the Milky Way are so enormous that if you reduced the Sun to the size of a grain of sand, the nearest star would be another grain of sand roughly 30 kilometers away, mostly empty space. Stars influence each other gravitationally, but they do not collide on any regular basis, do not physically interact in any way that resembles how atoms in a solid interact. When a galaxy rotates, it is not rotating like a wheel, where everything completes a full rotation in the same time. Different parts of the galaxy orbit at different speeds and take different amounts of time to complete their circuits. In fact, this is one of the most important puzzles in the history of astrophysics, known as the rotation curve problem. If a galaxy were made mostly of the visible matter we can see, the stars and gas concentrated in its disk and central bulge, then the stars in the outer regions should orbit more slowly than the stars closer to the center. That is what basic orbital mechanics predicts. The outer planets in the solar system orbit more slowly than the inner ones because they are farther from the concentrated mass at the center. A galaxy with all its mass in the visible disk and bulge should behave the same way. The outer stars should be moving slowly. The rotation speed should drop off with distance from the center. What this means is that our three-dimensional picture of the universe is actually a four-dimensional picture. Each object we see is at a different temporal depth. Nearby objects are seen nearly as they are now. Distant objects are seen as they were in the past. And the motion of all these objects means that the spatial distribution we see is not the spatial distribution that actually exists at any single moment in cosmic time. There is no way to take a simultaneous snapshot of the universe. Light speed imposes an irreducible delay that means we are always looking at a distribution of past states rather than a single present. This is profound. It means that the moving picture of the universe we construct from our observations is not the movie of the universe as it is. It is more like a strobe photograph, with each object captured at a different time, the nearby objects close to the current moment, and the distant objects frozen at progressively earlier stages of cosmic history. The motions we infer, the orbits and the expansion and the bulk flows, are inferences built from this multi-temporal snapshot, using the laws of physics to project backward and forward in time to construct a consistent picture. The two galaxies will then separate to some extent, decelerate, fall back together, and undergo a second pass. And then more passes, each time the combined system losing more orbital energy to the deformation and heating of the stellar distributions, until eventually, after 1 billion or more years of repeated interactions, the two systems settle into a single merged galaxy. The shape of this merged galaxy is predicted by simulations to be roughly elliptical, its spiral structure obliterated by the merger, a large, puffy ball of stars rather than the flat, rotating disks it came from. This collision is the destiny of the Milky Way. It is not an anomaly. Galaxy mergers are one of the primary mechanisms by which galaxies grow. The Milky Way has undergone several mergers in its past, evidence in the form of stellar streams of stars that have been gravitationally stripped from smaller galaxies that the Milky Way has absorbed, can be traced through our galactic halo. The Sagittarius dwarf galaxy is currently being torn apart and absorbed by the Milky Way. The large and small Magellanic Clouds, the two small irregular galaxies visible from the southern hemisphere as fuzzy patches of light, are in the process of being absorbed over the next several billion years. The Milky Way is a cannibal, and it has always been one. It grew to its current size partly by consuming smaller galaxies, and it will continue to grow by consuming Andromeda. The structure of the motion, why everything moves in these specific ways. We have been describing motion at multiple scales: rotation, orbital motion, galactic motion, cosmic expansion, but we have not yet addressed the deeper question of why the motion has the specific structure it does. Why disks? Why spirals? Why the specific orbital speeds and directions? Why does the universe look like this rather than like some completely different arrangement? The answer runs through two concepts that together explain almost everything about the large-scale structure of cosmic motion. The first is angular momentum. The second is gravitational collapse. Angular momentum is conserved. This is not just a useful rule of thumb or a good approximation. It is an exact symmetry of the laws of physics, a consequence of the fact that the laws are the same regardless of which direction you look, regardless of how you orient your reference frame in space. Conservation of angular momentum follows mathematically from rotational symmetry of the laws of physics, and it is as exact as any law in science. In any isolated system, the total angular momentum cannot change. It can be redistributed between parts of the system, but the total is fixed. When a cloud of gas collapses under gravity, it starts with some angular momentum. The cloud was part of a larger turbulent medium, buffeted by shock waves from nearby supernova, gravitationally nudged by neighboring gas clouds. This turbulence imparted a net rotation to the cloud, small compared to the total kinetic energy, but non-zero. As the cloud collapses, its radius decreases. For the angular momentum to remain constant as the radius decreases, the rotation rate must increase. Like a spinning figure skater pulling in their arms, the collapsing cloud spins up dramatically, and then there are the gravitational waves from compact object mergers, which we discussed in the reference material that prompted this script, and which bear repeating here in this context. Gravitational waves pass through you multiple times per week, somewhere in the observable universe. Black holes or neutron stars merge, releasing gravitational energy that ripples outward through space-time. That wave eventually reaches Earth, passes through the entire planet, through every person on it, stretching and compressing the geometry of space at the level of a tiny fraction of the diameter of a proton, completely undetectable by biology. Detected only by the extraordinary precision of laser interferometers that compare the lengths of 4-kilometer vacuum tunnels to a precision that required decades of engineering to achieve. The universe is not moving past you. You are inside the universe's motion. All of it. The dark matter is flowing through your cells. The neutrinos are passing through your body in their billions per second. The gravitational waves are moving through you weekly. The expansion of the universe is carrying you along with everything else in the local group, inseparable from the motion you are embedded in. Your atoms are rotating with the planet, orbiting with the solar system, sweeping through the galaxy, riding the gravitational flow toward the Shapley supercluster, all simultaneously, all unfelt, all real. The universe has never been still. It will never be still. It began in the most violent possible way, an event that set everything in motion simultaneously, and it has been elaborating that motion into structure ever since. Stars, galaxies, clusters, the cosmic web, all of it the organized consequence of initial velocities and density fluctuations working through 13.8 billion years of gravitational dynamics. That field, those stars, that frozen ceiling, it is a river. It has always been a river. We were just too small and too brief to see it flow. You have been watching the entire history of the universe. Do not forget to like and subscribe and leave a comment to tell us what you think. Thanks for watching, and we will see you next time. The increasing rotation creates a centrifugal effect. The collapse along the rotation axis, the poles of the rotating cloud, is not resisted by rotation. The material along the axis can fall straight in, but the collapse perpendicular to the rotation axis in the equatorial plane is resisted by the rotational motion. The material in the equatorial plane cannot fall straight in without gaining angular momentum it does not have, so it settles into a disk, orbiting at whatever radius allows its angular momentum to balance the gravitational attraction. This is why everything with angular momentum forms a disk when it collapses. Protoplanetary disks, galactic disks, accretion disks around black holes. The disk is not a coincidence. It is the inevitable shape of a collapsing, rotating system. And since essentially every real cloud has some net angular momentum, disks are essentially inevitable. The universe defaults to disks when things collapse. The second concept, gravitational collapse, explains why the universe has structure at all. The early universe was almost perfectly smooth. The density variations, the ripples of higher and lower density left by quantum fluctuations during inflation, and then modified by acoustic oscillations in the hot plasma of the early universe, were tiny. 1 part in roughly 100,000. But they were not zero. And over billions of years, gravity amplified them. The slightly denser regions attracted more matter from their surroundings. As they grew denser, they attracted more matter, getting denser still. The slightly less dense regions lost matter to their denser neighbors, becoming emptier. The rich got richer and the poor got poorer, gravitationally speaking, and the result over several billion years was the cosmic web. Filaments of gas and galaxies stretching between massive nodes where galaxy clusters formed, separated by enormous voids that became increasingly empty as their matter was gravitationally drained into the filaments and nodes. Our solar system has passed through multiple spiral arms over its history. The current arm we are in or near is called the Orion Arm, and the last time we were in a major arm before this one was roughly several 100 million years ago. Some researchers have suggested that passages through spiral arms may have triggered ice ages on Earth by exposing the solar system to slightly different cosmic ray fluxes or to denser regions of interstellar gas. Whether these correlations are real and significant is debated, but the idea that the galactic scale motion of the solar system could have biological consequences on Earth is not a fringe idea. It follows directly from the fact that we are moving through a structured galaxy whose properties vary from place to place. This matters enormously for how you picture the universe's motion hierarchy. The expansion is a backdrop against which all the other motion happens. On top of the expansion, there are the peculiar velocities, the motions of galaxies relative to the expansion, caused by the gravitational interactions of the actual matter distribution. The Great Attractor and the Shapley supercluster are pulling the Milky Way and its neighbors toward them because there is a real concentration of mass there, and gravity is doing what gravity does. These motions are real additional motions on top of the background expansion. In regions where matter is dense enough, like galaxy clusters, gravity can completely halt the local expansion and even reverse it. The Andromeda Galaxy is approaching us, not receding, because it is close enough, and the local gravitational attraction between the two galaxies is strong enough to overcome the cosmological expansion between us. The expansion is a global phenomenon. Locally, gravity wins. But on scales large enough that the matter distribution averages out, on scales of hundreds of millions of light years and above, the expansion dominates. Distant galaxy clusters are receding from us at speeds that increase with distance. Clusters at the edge of the observable universe appear to be receding at speeds exceeding the speed of light. This is not a violation of relativity. It is the expansion of space itself, which is not subject to the speed of light limit that applies to the motion of objects through space. Space can expand faster than light. The objects in that space are not themselves moving through space at those speeds, and the expansion is accelerating. This was discovered in 1998 by two independent teams studying distant Type 1a supernovae, standard candles that can be used to measure distances across cosmological scales. What they found was that distant supernovae were slightly dimmer than expected, meaning they were farther away than a universe decelerating under its own gravity should place them. The expansion was not slowing. It was speeding up. Something was driving the accelerating expansion. That something was named dark energy, and it currently constitutes roughly 68% of the total energy content of the universe. Its nature is one of the deepest unsolved problems in theoretical physics, but the picture it gives you of where you are, of what you are embedded in, of what this universe actually is as a physical system, that picture is profoundly different from the one the frozen ceiling of lights suggests. The universe is not a place where things sit and where drama happens occasionally in exotic locations. The universe is motion, organized, hierarchical, layered motion from the quantum level to the cosmological, running continuously, driven by the fundamental forces in the structure they impose on matter and energy. You are not an observer looking at the universe from outside. You are inside it. You are part of its motion. The rotation carries you. The orbit carries you. The galactic motion carries you. The flow toward the supercluster carries you. The cosmic expansion carries you, along with everything in the local group together as a unit, away from everything else. The stillness is real. It is the stillness of a passenger on a ship, carried by the sea, feeling no motion because the ship is moving with them. The sea is not still. The ship is not still. The passenger is not still. But from inside it feels like rest. What will happen over the next several billion years is a series of passes. The first close approach, in roughly 4 billion years, will bring the visible disks of the two galaxies sweeping through each other. This is not a collision in the sense of two solid objects hitting each other. The stars in each galaxy are so far apart, relative to their own sizes, that actual stellar collisions will be extraordinarily rare. What will happen is that the mutual gravity will distort the shapes of both galaxies dramatically. Long tidal tails of stars will be stripped out. The spiral arms will be disrupted. Gas clouds will be compressed by the interaction, potentially triggering enormous bursts of star formation. The appearance of both galaxies will be transformed on timescales of hundreds of millions of years. The estimates depend on assumptions about the dark matter particle mass and velocity distribution, but by most models, roughly 10 to the power of 6 or 10 to the power of 7 dark matter particles pass through every cubic centimeter of space every second, through the cubic centimeters of your body. They pass through without interacting, without depositing energy, without leaving any trace. They pass through you the way sunlight passes through glass, except more completely, without even the small fraction of absorption that glass produces. The dark matter is functionally transparent to ordinary matter, and ordinary matter is functionally transparent to it, except through the weak grip of gravity, which at the scale of individual particles and centimeters is utterly negligible. And if dark matter is flowing through you, so too, potentially, are neutrinos. Neutrinos are produced in enormous quantities in the sun's core, and in supernova and in other high-energy astrophysical events. They interact with ordinary matter only through the weak nuclear force, which makes them extremely penetrating. About 65 billion solar neutrinos pass through every square centimeter of your body every second, day and night, when the sun is above or below the horizon. At night, they pass through the entire Earth before reaching you. The Earth is not a significant barrier. For a neutrino, the Earth is nearly transparent. The cosmic web is not a static structure. It is an evolving one. The filaments are feeding material into the clusters at their nodes. Galaxies are moving along the filaments toward the clusters. The clusters themselves are growing by incorporating galaxies that fall in along the filaments. Everything in the cosmic web is in motion toward the nearest gravitational center of concentration. On small scales, toward the local galaxy cluster. On larger scales, toward supercluster nodes. On the largest scales, the motion is dominated by the expansion and the particular geometry of the dark matter and dark energy distribution. The specific pattern of motion we observe, our local group falling toward the Great Attractor and the Shapley supercluster, is just our local portion of this cosmic web dynamics. We are on a filament of the cosmic web, being swept along it toward a larger concentration. The motion is not arbitrary. It reflects the three-dimensional structure of the dark matter distribution in our part of the universe, built up over billions of years of gravitational collapse from the nearly smooth initial state. What moves through us? This is the part that should change something in how you picture your relationship to all of this. Because the motion we have described is not happening at a safe cosmological distance, operating somewhere out there while you sit still and observe. You are inside it. You are part of it. You are moving through space at hundreds of kilometers per second, being carried in nested orbits that layer on top of each other, embedded in a flow of matter toward a supercluster attractor 300 million light-years away. All of it unfelt, all of it invisible, all of it real. But it is not just that you are moving through space. The objects in space are moving through you. Dark matter is the dominant component of matter in the galaxy by mass. Roughly 5 times more dark matter than ordinary matter. The dark matter halo of the Milky Way extends to perhaps 10 times the radius of the visible disk, forming an enormous, roughly spherical distribution of whatever dark matter actually is at the particle level. We know it is there because of its gravitational effects on galaxy rotation curves, on the lensing of background light, on the large-scale structure of the universe. We do not know what it is, whether it is one type of particle or several, whether it interacts with ordinary matter in any way beyond gravity. But if dark matter exists in the halo of the galaxy, and the solar system is inside the halo of the galaxy, then dark matter is flowing through the solar system right now. Not in a dramatic sense, not in a way that has any detectable effect on anything at the scales we can observe directly, but in the sense that if you model the dark matter distribution in the halo and the motion of the solar system through the halo, you can estimate the flux of dark matter particles through any given volume of space, including the volume you currently occupy. Our sun, the solar system, everything will still exist during and after all of this. The solar system is not going to be destroyed. Individual stellar collisions are so rare that the sun is extremely unlikely to directly interact with another star. What will change is the sky. The view from Earth in 4 billion years, or from whatever Earth has become by then, will show an enormous galaxy spreading across the sky, far larger in angular extent than anything in our current sky. A signature of the ongoing merger written across the entire celestial sphere. Eventually, everything beyond the local group will have receded past the event horizon. Signals from those galaxies sent today are already on journeys that will never complete, and signals we are sending today are already unable to reach the most distant galaxies. The universe is in the process of tearing itself apart, slowly, on cosmological timescales, into isolated islands. Gravitationally bound structures, galaxy clusters, groups, and individual galaxies will persist as islands of matter held together by their own gravity. But between these islands, the space will grow and grow without limit. In the far future, the merged Milky Way Andromeda galaxy, whatever it is called by then, will sit at the center of its own observable universe, surrounded by emptiness, stretching in every direction. The other galaxy clusters that we can see tonight will be gone from any possible future observation. The evidence for the large-scale structure of the universe, the cosmic web, the clusters and filaments and voids, all of that will have receded past the horizon, leaving no trace in the sky visible from our future island. Future observers in that era, if any exist, will see a universe that appears to consist of a single galaxy surrounded by apparent emptiness. They will have no evidence from their observable sky that any other structure ever existed. The rich history of mergers and interactions and large-scale flows that we can read in the current sky will be completely invisible to them. This is one of the more striking implications of the accelerating expansion. We are in a fortunate epoch in the history of the universe, when the large-scale structure is still visible, when the motions that created it are still readable in the galaxy distribution and the velocity fields. In the distant future, that record will be erased. What is happening is this: right now, tonight, if you go outside and look up at the stars, you are riding a planet that is moving at up to 1,670 kilometers per hour, relative to the axis beneath your feet, orbiting a star at 30 kilometers per second, which is orbiting the galactic center at 230 kilometers per second, all of it embedded in a local group moving at 600 kilometers per second toward the Shapley supercluster, all of it immersed in a universe that is expanding at an accelerating rate, carrying distant galaxies away from us at speeds that grow with distance. The stars you are looking at are not sitting in the positions you see them in. They have been traveling since the light you are seeing was emitted. They are currently somewhere else. In 10,000 years, they will be somewhere quite different, and the constellations will be unrecognizable. The Milky Way band is the light of a rotating disk of stars that has been turning for 10 billion years and will continue turning for billions more. The neighboring galaxy, Andromeda, is approaching at 110 kilometers per second and will eventually collide with this one. None of this is cause for alarm. None of it will affect anything on any human timescale. The orbital motions are stable. The galactic collision is billions of years away. The expansion is imperceptible on any scale that matters for daily life. And the disk does not rotate uniformly. The spiral arms that give spiral galaxies their name are not fixed structures. They are density waves, patterns of higher density that move through the disk at a different speed from the stars themselves. A star moves through a spiral arm, the way traffic moves through a congested stretch of highway. The congestion is a pattern that moves at its own speed. Individual cars pass through the congestion and emerge from the other side. The congestion is real as a structure, but it is made of different cars at different times. The spiral arms of the Milky Way are real as structures, regions of higher star density and higher rates of star formation, but the stars move through them rather than the stars being fixed members of them. And in recent decades, a more sophisticated version of this technique has transformed our understanding of the universe's velocity field at the largest scales. Surveys of the peculiar velocities of hundreds of thousands of galaxies, measuring their Doppler shifts and comparing them to the distances inferred from their redshifts minus the expansion contribution, allow cosmologists to map the three-dimensional flow of matter across enormous volumes of the universe. These surveys have revealed the flows toward the Great Attractor and the Shapley supercluster. They have confirmed that our local group is caught in a bulk flow that extends across much of the observable universe. They have begun to reveal the three-dimensional topology of the cosmic web that drives all these flows. The most ambitious of these programs, The cosmic flow surveys led by Brent Tully and collaborators have produced three-dimensional maps of the peculiar velocity field across a volume of hundreds of millions of light-years. And from this data, Tully's group published in 2014 a redefinition of what we mean by the Milky Way's home. They identified a structure they called Laniakea, from the Hawaiian word for immeasurable heaven, which is the supercluster of galaxies to which the Milky Way belongs. Laniakea is defined not by a clump of visible matter, but by the basin of gravitational attraction, the region from which all the peculiar velocity flows are converging toward a common central attractor. Laniakea spans roughly 500 million light-years and contains the mass of 100 quadrillion suns. The Milky Way is not at its center. We are in the outer suburbs, one of 100,000 galaxies caught in the gravitational pull of this enormous structure, all flowing toward its central attractor. Our place in the cosmic web is now better defined than it has ever been, and it is humbling. We are a small galaxy in the outer regions of a supercluster that is itself one structure among many, in a universe that contains hundreds of thousands of similar structures spread across 93 billion light-years of observable space. And this process is not unique to our local group. Everywhere you look in the universe, at the largest scales where we can observe structure, you see the evidence of mergers. Elliptical galaxies, which are more common in denser environments, like galaxy clusters, are thought to be the end products of repeated mergers. The shells and streams visible around many ellipticals are the fossil signatures of past absorption events, stars from consumed galaxies that have not yet fully mixed into the main body. The universe's history is a history of mergers, of structures falling together under gravity, growing, falling together again, growing further. The motion is not random. It is organized by gravity into a hierarchy of collapse and structure formation that has been running since the Big Bang. The practical consequence of accelerating expansion is that the observable universe is getting smaller in the relevant sense, not the sphere of past light, which is fixed by the age of the universe, but the sphere of future influence. The region with which we can still exchange signals is contracting. Galaxies beyond a certain distance are already receding faster than light can catch them. Signals we send today will never reach them. Signals they are sending today will never reach us. The universe is not just moving. It is moving in a way that is progressively isolating its parts from each other. In the far future, if life persists long enough, the observable universe from any vantage point will consist only of the local gravitationally bound cluster. Everything beyond it will have receded past the horizon of causal contact, Hubble's discovery, and what it actually means. In 1929, Edwin Hubble published a paper that represented one of the most significant observational discoveries in the history of science. He had been measuring the distances to galaxies using Cepheid variable stars, a type of star whose pulsation period is directly related to its intrinsic luminosity, making them usable as standard candles. And he had been examining the spectra of these galaxies, which showed systematic redshifts, shifts of spectral lines toward longer wavelengths that were greater for more distant galaxies. The relationship he found was linear. Double the distance, double the recession velocity. The universe was expanding. Every galaxy was moving away from every other galaxy. The space between galaxies was stretching, carrying the galaxies apart in a way that was not the motion of objects through space, but the expansion of space itself. But here's the thing about Hubble's discovery that is easy to misunderstand, and the misunderstanding has consequences for how you picture the universe's motion. The expansion is not a motion with a center. When you hear that galaxies are moving away from us, that everything is receding, the immediate temptation is to picture the Milky Way at the center of the expansion, with everything else flying outward from us. That picture is wrong. Not just approximately wrong, structurally wrong. The expansion of the universe is like the surface of a balloon being inflated. Every point on the balloon's surface moves away from every other point as the balloon inflates. There is no special center on the surface. Pick any point you like, and from that point, every other point appears to be moving away, with more distant points appearing to recede faster. The point you picked is not special. The same is true from any other point. The expansion looks the same from everywhere, not because everywhere is the center, but because there is no center. The expansion is a property of the space itself, not a motion of objects through space from some central origin point. Time and the motion we cannot observe directly. One of the things that makes cosmic motion philosophically disorienting is the relationship between the motion and time. When you look at a star 100 light years away, you are seeing it as it was 100 years ago. The light that is reaching your eyes tonight left that star 100 years ago. The star you are seeing is not where it actually is right now. In 100 years of travel, the light has crossed the distance, but in that same 100 years, the star has continued along its orbit around the galactic center at 200 or 250 kilometers per second. It has moved a significant distance from where it was when the light you are seeing was emitted, where the star actually is right now, where it will be when your light reaches it in another 100 years. Neither of these things is what you are seeing. You are seeing a snapshot 100 years old. For the Andromeda Galaxy at 2.5 million light years, you are seeing it as it was 2.5 million years ago. In the time since that light was emitted, Andromeda has moved measurably along its path toward us. It is closer than the light you are seeing suggests. The galaxy you see tonight is not the galaxy as it is. It is the galaxy as it was, when the ancestors of humans were just beginning to fashion stone tools in East Africa. This temporal parallax extends to every astronomical observation. The cosmic microwave background represents the universe as it was 380,000 years after the Big Bang, 13.4 billion years ago. The most distant galaxies visible in deep field images are seen as they were when the universe was only a few 100 million years old. They no longer look like those images. They have evolved enormously in the 13 billion years since that light was emitted. Some of them no longer exist as independent galaxies. They have merged with neighbors. Their forms have been transformed by billions of years of dynamics. The image in the telescope is an archaeological artifact, not a current reality. What this means for the motion of the galaxy is that when the Milky Way rotates, it is not just the visible disk rotating. It is the visible disk rotating inside an enormous spherical dark matter halo that is also in motion. The dark matter halo does not rotate like a disk. It has its own complex motion, partly rotating and partly in disordered orbital motions that form a sphere rather than a flat structure. The galaxy we live in is a flat, rotating disk of stars and gas, sitting inside a fuzzy, spherical halo of invisible mass that is itself in a complex, churning motion. The collision that is already underway. This is the part that often gets described as something that will happen, as a future event, as something remote and not particularly relevant to anyone alive today. But framing it that way misses something important. The collision between the Milky Way and the Andromeda Galaxy, the largest galaxy in our local group, sitting roughly 2.5 million light-years away, is not merely a future event. It is an ongoing process. It has already started. We are already in it. The final realization. Come back to that field. Stars overhead, sky without interruption, Milky Way crossing from horizon to horizon. It looks like a ceiling of frozen lights. It is not. Every point of light in that sky is moving. Every star has its own velocity, its own orbit around the galactic center, its own proper motion relative to the sun. The apparently fixed pattern of constellations, the shapes that human cultures on every continent have named and made stories of, are not fixed. They are a snapshot. Orion looks the way it does because we happen to be seeing the stars that form it at this particular moment in their individual journeys through the galaxy. 50,000 years from now, Orion will not look like Orion. 100,000 years from now, the night sky will be unrecognizable compared to what we see tonight. The constellations are accidents of timing, patterns that exist for a geological eye blink, because the stars that form them happen to be near each other, in projection at this moment. The Milky Way band crossing the sky is the view across the plane of the galactic disk, the accumulated light of hundreds of billions of stars seen edge-on from our position inside the disk. That disk is rotating. The stars in that band are not still. They are orbiting the galactic center at hundreds of kilometers per second, each in its own orbit, each on its own trajectory. The disk has been rotating for 10 billion years, and it will continue rotating for billions more. Every star you can pick out in it tonight was somewhere completely different 100 million years ago, and the galaxy itself is in motion. The entire Milky Way is falling toward Andromeda and the center of the local group. The local group is flowing toward the great attractor. The whole assembly is caught in the cosmic web, flowing in the gravitational field of structures that span hundreds of millions of light years. And the space between everything is expanding, being stretched by dark energy at an accelerating rate, carrying all these structures apart on the scales where gravity cannot hold them together. The universe is motion all the way up and motion all the way down. There is no scale at which things sit still, not the scale of atoms, where the electrons are in their quantum probability distributions rather than sitting in fixed locations, and the nucleus is a dense sphere of quarks in constant motion held together by the strong force. Not the scale of molecules, in constant thermal agitation even in cold solid matter, vibrating and rotating in the lattice. Not the scale of rocks and planets, rotating on axes and orbiting stars. Not the scale of stars orbiting galaxies. Not the scale of galaxies orbiting within clusters and superclusters and flowing in the gravitational field of the cosmic web. Not the scale of the universe itself, expanding in every direction from every point, carrying all structure apart in the void between gravitationally bound systems. The word stillness has no referent in the physical universe. It is a local experience, the result of sitting inside a reference frame where everything around you is moving at the same rate, and your sensors are designed to detect relative motion rather than absolute motion. It is real as an experience. It is accurate as a description of your sensory state, but it is not a description of what is actually happening in the physical world around you. the motion that defines where we are going, the Andromeda collision in 4 billion years, the cooling of the Sun into a white dwarf in 5 billion years. The eventual isolation of the local group as dark energy pushes everything else past the horizon. The eventual cooling of the white dwarfs into black dwarfs over trillions of years. The evaporation of black holes through Hawking radiation over incomprehensibly longer timescales. The large-scale motion of the universe is not just the history of where things have been. It is the trajectory of where things are going. The particular set of motions in play right now, this configuration of velocities and masses and trajectories, leads to specific futures. Not just the Andromeda collision, which is essentially guaranteed at this point, but the entire long-term evolution of the universe as a physical system. And the most important driver of the future motion is dark energy. Dark energy is driving the accelerating expansion. As time goes on, the expansion between any two objects that are not gravitationally bound to each other gets faster. Objects that are currently receding slowly will eventually reach speeds at which their recession exceeds the speed of light, and they will disappear from our causal horizon. The observable universe is shrinking in the relevant sense, not the sphere of past light, but the sphere of ongoing connection. Vera Rubin and Kent Ford measured the rotation curves of galaxies starting in the 1970s, and what they found was that the outer stars were not moving slowly. They were moving at roughly the same speed as the stars closer to the center. The rotation curves were flat, where they should have been declining. The only way to explain this was to assume that there was additional mass present that the telescopes could not see, distributed in a large spherical halo extending far beyond the visible disk. Dark matter, the invisible component that makes up the vast majority of a galaxy's total mass, distributed in a roughly spherical cloud that extends to many times the radius of the visible disk. The Andromeda Galaxy is currently approaching the Milky Way at approximately 110 kilometers per second. Some analyses suggest the approach speed may be higher. At 110 kilometers per second, it is closing the gap at a rate that will bring it to the point of first close approach in roughly 4 billion years. But the gravitational interaction between the two galaxies is not waiting for the first close approach to begin. Gravity has no minimum range. The Milky Way and Andromeda are already exerting measurable gravitational effects on each other right now. Their dark matter halos, which extend far beyond their visible disks, are already overlapping, or very nearly so. The tidal forces between them are already affecting the outer regions of both galaxies.